0 ଅଛନ୍ତି ଏବେ
ତାଙ୍କୁ ପଠେଇ ଦିଅ ଲିଙ୍କଟା ପଠେଇ ଦିଅ ତାହେଲେ ଆସିବେ
ଲାଇଭ୍ ଆସିନି ଯାଇନାହାନ୍ତି ତଳେ ଦେଖିଲେ ଆସିଲେ 0 ନା ଲାଇଭ୍ ପବ୍ଲିଶ ହେଇନି
ଆସିଲା କଲିବା ନାଇଁ
ହଁ ଠିକ୍ ଅଛି ଏବେ ଠିକ୍ ଅଛି
ଲିଙ୍କ ପଠା
ଲିଙ୍କଟା ଟିକେ ପଠେଇଲୁ
ଏ କ'ଣ ରେକର୍ଡ଼ିଂ ଚାଲିଛି
ହଁ ଷ୍ଟାର୍ଟ ହେଇଛି ଏଇଠି ଦେଖେଇଦେବେ ଏଇଠି କ୍ଲିକ୍ କରିଦେବେ ଦେଖିବେ କେତେ ପିଲା ଏବେ 0 ଅଛନ୍ତି ଆସିବାକୁ ପଠେଇଦେବେ ହଁ ପଠେଇଦେବେ ଲିଙ୍କ ପରେ ଆପଣ ସେୟାର କରିଦେବେ
ମୋତେ ପଠେଇଲୁ
यहाँ पे कहलु ना टैब भी जाऊँगी
हाँ
कंप्यूटर हाँ पढ़ते लिंक हाँ हाँ जॉइन करते देखते केते जन छह जन 4 जन 6 जन जन
अरे जॉइन कर हाँ हाँ এটা ପବ୍ଲିଶ କରିବାନି ହେଲା କି 11 ଜଣ ଜଏନ୍ କରିବାନି ଷ୍ଟାର୍ଟ କରିଦେବା yes then I will start message ପାଇଁ ଗୋଟେ ଅଛି हाँ just put a message if this voice and video is clear then I will start कोड़े जन सिलेंडर हाँ Okay, so let us now start with the game theory. Okay, so coming to the game theory, every competitive situation is a game, right? Every competitive situation is a game. Maybe the election campaigning, right? It is also a game. The advertisement in business sector, it is also a game, right? So basically such type of games involve the strategies. That means every competitive situation is a game such that it has certain following properties. It has following properties. I will not write the property in details. In individual lecture you will see the properties. So that means there are finite number of participants. There are finite number of participants. Okay, each participant has finite number of strategies, right? Finite number of strategies, right? And when each player adopts a strategy, then the game is played. Okay, accordingly the other properties you should see it. Now coming to the definition of two-person zero-sum game. What we need? What is a two-person zero-sum game? Two-person zero-sum game. In two-person zero-sum game, okay, there are two persons involved in this game, and the net gain by all the players is 0. That means, suppose player A and B are playing a game. Player A and player B. Player B. Both the players are playing a game. Right. Player A is having the strategy, you say A1, A2, so on, AN. Player B is having the strategies B1, B2, Bn. You call it M and you call it M. Right. It is a M cross N matrix, say. So now, when player A adopt one strategy, player B adopt one strategy, the game is being played. Now, this is suppose A11, means this payoff matrix is in view of the player A, right? By convention, by general convention, we write it in the viewpoint of the player A. The player what is being written in the left hand side, on that basis this payoff is written. So while A1 selects strategy 1, B selects strategy B1, then the payoff, the gain to this player A is A11. And similarly, while A1 and B2, it is A12, likewise it is A1n. Then similarly A21, A22, so on, A2n. And accordingly AM1, AM2, so on, AMN. So this is the payoff. That means by saying here Aij, what does it mean? By saying Aij means this is the payoff to player A, or I can say the gain to player A, when A choose ith strategy, and B chooses jth strategy, right? Now the same game, if we want to see it from the viewpoint of B, now this is if I write from the viewpoint of B, if I write player B here, player A here, okay, that means I am writing the same game from the viewpoint of B, means this is the payoff for the player A, means here the gain for the player B will be minus A11, and it is minus A12, likewise minus A1n, minus A21, minus A22, and so on, minus A23. And if you continue like this, it is minus AM1, minus AM2, and it is minus AMN. So now if you find the sum of this, means if you find the sum of this, right, then this net gain is 0, okay, then this will be a null matrix, right? This will be a null matrix. Clear? So this is a null matrix. That means here the net gain is 0. So here two-person zero-sum game means there are two players, right? Okay, and the payoff is written from the viewpoint of the player, written in the left hand side, and it is such that the net gain is 0. For example, in particular, suppose I am saying suppose a player A is having two strategies. A1 and A2. Player B is having three strategies, B1, B2 and B3. Okay, suppose the game is like this. Suppose this is my 2, this is my minus 3, this is my 5, this is minus 4, this is 7, this is 9. Right, by saying this minus 3, what does it mean? By saying this minus 3, it mean the gain of player A is minus 3. Okay, the gain of player B If it is minus 3, then it is a gain to player B. The gain of player A. Player A is, sorry, this is A is minus 3, B is here plus 3. Right. Now the moment I say suppose my 2 I say. So that means on the basis of 2, the gain of A is equal to 2, and the loss of, or the gain of B is your minus 2, right? The gain of B means if it is positive, then it is a gain to A, and the negative of that is the gain to B. So what is the net gain? The net gain is here 0. So it is called a 2% zero sum game. Okay. So now we come across two words. One is the payoff. Okay. So what is a payoff? Payoff matrix. Then we know what is the payoff to individual players. Okay. Payoff to individual players. Now by solving a game, what do you mean solve? Suppose you are asked that solve a game. Solve a game means, what we exactly mean? We mean to find the value of the game, and then we have to find what is the best strategy for the players. Right. So this is the basic thing. By solving a game, we mean it. Right. So now the case is that what is a maximin and minimax criterion? The most important criterion here is the maximin and minimax criterion. Maximin and minimax criterion. So the maximin and minimax criterion says that you have two players. As I have told you, we are talking about the two players. So player A and player B, right? In particular, suppose I am writing, this is my 1, 3, 1, and it is suppose my 0, minus 4, minus 3, 1, 5 and minus 1. So means the player A you write it, player B you write it. So A is having the strategies A1, A2, A3. B is having the strategies B1, B2 and B3. Now the viewpoint of A, what is the viewpoint of A? You see, the viewpoint of A is the player, what is being written over here, the viewpoint is you maximize the profit, right? The viewpoint is maximize the profit. So while it maximize the profit, B is not going to sit idle. There is a protest by B, right? Maximize the minimum profit. So this is the objective of A. The objective of B here is, right? The objective of B here is to minimize the loss. So minimize the maximum loss. Right? So this is the viewpoint from player A and player B point of view. So from the point player A point of view, we have to find the row minima. First. And from the player B point of view, we have to find the column maxima. Suppose this row minima, I mark it by a star. So in this row, the row minima is 1. I write it here 1. In this row, the row minima is here minus 4. I write it minus 4. In this row, the row minima is minus 1. I write it minus 1. Okay. Then from the player B point of view, what is the column max? The column max in this column, I mark it suppose by plus. And in this column, it is this. In this column, the maxima is this. Okay. Right. Column maxima. So here it is year 1. Here it is year 5. Here it is year 1. Now I find the maximin value. Okay. Maximum of these three. 1, minus 4 and minus 1. Okay. This is year 1. Right. Means this is the minima. These are the minima. Okay. So what we find? We find the maximin value. The maximin value is 1 here. And here this is already the maximum value. we find the minimum of this. We find the minimum of this. Okay, minimum of 1, 5 and 1. So this is already the max value. So we call it minimax value. Minimax value. Right, the minimax value is here. The minimum value here is 1 here. And you see, and this maximum value here is equal to the minimax value. Now you see the point where both star and plus are being marked, okay, is your maximum and minimax value. So what is maximum minimax criterion? Now this criterion says if the maximum value, right, maximum value is equal to minimax value, right, minimax value, then it is the saddle point, which is equal to the saddle point, or which is equal to the equilibrium point, and this value is called the value of the game, which is the value of the game, right, value of the game. And so what is the value of the game? The value of the game is 1 here. Now corresponding to this 1, right, right, the best strategy for A is A1, and here for B we have two strategies, B1 and B3, right. So corresponding to V, right, so for this value corresponding to here B, the corresponding strategies are best strategies or optimal strategies here. So the optimal strategy, therefore optimal strategy for A is A1, and optimal strategy for B is here B1 and B2, B1 and B3. You see, B1 and B3. So we have three strategies, B1 and B3, right? So this is the optimal strategy for your B. Now the situation arises when we don't find a pure strategy. So this maximum and minimax principle, right, and this will give you the pure strategy here, pure strategies. Now if there is no pure strategy, if we don't find a maximum and minimax value, right, what will happen? If maximum is not equal to minimax, then what will happen? This implies there is no saddle point. What does it mean? This implies it leads to mixed strategy case. And we have the probabilistic approach. So in this probabilistic approach, what we will see, now it is basically discussed at the beginning for a 2x2 payoff matrix, right? So if the matrix is a 2x2 payoff matrix, then we directly apply the formula here. If it is not a 2x2 matrix, then we try to reduce this matrix. Okay. So coming to suppose you are given, so my next heading is the mixed strategy for 2x2 payoff matrix. Suppose you are given a 2x2 payoff matrix, right? You suppose consider A11, A12, A21, A22. This is for your player A. This is for your player B, and it is my B1, it is my B2, and it is my A1, it is my A2. Now here I apply, suppose there is no saddle point. Then what is the value of the game? The value of the game here is this into this, A11 into A22 minus this into this, A12 into A21, divided by your A11 into this is plus A21 minus A12 plus A this is A22, okay, plus A11, A22, A12, A21, okay. So now since this denominator is going to be used throughout, I just mark this denominator by my some lambda say. I mark it say lambda say, right? So now my V is my A11 into A22 minus A12 into A21, this divided by my lambda. So now let the mixed strategy for A is, we have A1, A2, I denote it SA. SA is my A1, A2, and the probabilistic case here P1, P2, such that P1 plus P2 is equal to 1. P1 plus P2 is equal to 1. Similarly, mixed strategy for B is what? Mixed strategy for B is what? For B, we have SB is here B1, B2, Q1, Q2, such that Q1 plus Q2 is equal to 1. Now we have to know what is P1 and what is P2. The formula for P1 here is, already the matrix given is A11, A12, A21, A22, and we have P is this minus this by lambda, okay. A22 minus A21 divided by lambda. Then what is your P2? P2 is 1 minus P1. Accordingly, we find. Now what is your Q1 now? Your Q1 will be this minus this, okay. A22 minus A12 divided by lambda. Once you find this, automatically your Q2 will be 1 minus Q1. So now after getting Q1, Q2, P1, P2, we just substitute our here and here, and this will give me the mixed strategy. So let me to solve one example. Suppose you are given one example in a coin tossing scheme. Right. Player A and B matches 2 coins. If matches by two players, okay, by 2 players A and B. If coins match, A wins half a unit. Otherwise B wins half a unit. Okay. So we just display the game and solve it. Coming to the solution. So now we have the coin tossing scheme here. So head and tail here. The player A, the player B here. Now if matches head and head, here it is match. So A win half a unit means it is half. Here it is head and tail, doesn't match. So B win means minus of half. Okay. Then here tail and head doesn't match. So B wins means minus half. Now it is matching tail and tail here. So A wins means half a unit. So this is the game. So it is of the form A11, A12, A21, A22 now. Okay. So now here what is the value of the game? So the value of the game, V will be equal to, what is first you find lambda? Your lambda is equal to this plus this minus this plus this. This is half plus half minus half, this plus this. Half plus minus half minus half. Okay, so it is plus half minus half minus half. This plus this minus this plus this. So it is minus. So this is here 1 plus 1 is equal to 2. Lambda is here 2. So now what is the value of the game? The value of the game V will be here A11 into A22 minus A21 into A22 A12 divided by lambda. So this will be here. So this will be here 1 by 4 half into half minus half into minus half into half divided by lambda is 2 is your 0. So the value of the game is 0. Now let your mixed strategy. Your essay is A1, A2, P1, P2 and SB is B1, B2, Q1, Q2. So what is your P1 now? We find P1. Your P1 will be, this is half minus half and half. Okay. So this minus this by, so this will be half minus half by lambda. So this is half now. Then what is your P2? Is 1 minus P1 is here again half. Similarly, what is your Q1 now? Your Q1 will be this minus this. So this is again half minus half by lambda. So this is 1 by 2. Okay. So this implies what is your Q2? 1 minus Q1 is 1 minus half is your half now. So therefore the mixed strategy, thus the mixed strategy for A and B are respectively SA is A1, A2 half and SB B1, B2 half with value of the game, V is equal to your 0. Okay. So now the thing is that higher order matrix. Suppose you are given a higher order matrix, M cross N matrix. Then what to do? No saddle point. Suppose no saddle point here. No saddle point. Then we want to reduce it. Reduce it to a 2 cross 2 matrix. This reduction is by using your dominance rule. We reduce it. And this reduction is by dominance rule. So what is my dominance rule now? You see, next thing is my dominance rule. Coming to the dominance rule. In dominance rule, what we will do? The rule is like this. Your larger row will dominate the smaller row. Rule number 1, larger row dominates the smaller row. What does it mean? Mean, suppose you have the row 2, 3, 5, 7, 4, 5, 6, 7, 3, 2, 1, 5. Suppose this is a matrix here. This is my player A, A1, A2, A3, and this is suppose my player B, here B1, B2, B3, B4. So now you see here. If you compare this row with this row, right? You see the individual position. 4 is greater than 2, 5 is greater than 3, 6 is greater than 5, 7 is equal to 7. So I can write it here. Row 2, this is my row 2, this is my row 1, this is my row 3. So row 2 is superior to row 1 in corresponding positions. Okay, in corresponding position. Right, row 2 is superior to row 1 in corresponding position. So this larger row will be there, smaller row will be dominated. Okay, so therefore R1 is dominated by R2. So it can be removed now. So what is the reduction now? So the reduction here is this row will be dominated and removed. This is 4, 5, 6, 7, 3, 2, 1, 5. Okay, so now it is reduced. Accordingly, we go on reducing. Coming to rule number 2, smaller column will dominate the larger column. Right, smaller column smaller column dominates larger column, right? Smaller column means suppose my 157 298 312, right? So you see here, so this column is a smaller column. This 1 is smaller than 2, 5 is smaller than 9, 7 is smaller than 8. So this column will be dominated, right? Here C1 is smaller than C2, so or smaller than equal to, then what will happen here? This smaller column will be there, larger column will be dominated. So this C2 will be dominated. So the reduced matrix here will be 157, then 312. In that way this reduction can be done. Now coming to the rule number 3, the convex combination of row and column also follow 1 and 2. Convex combination of rows and columns follow rule 1 and rule 2. Rule 1 and rule 2. What does it mean? That means to say, suppose here R1 plus R2 plus R3 divided by 3, average of these 3, okay, is superior to some R5, say, then what will happen? This R5 will be dominated, okay. So then here R1, R2, R3 will be there. This implies R5 is dominated. R5 is dominated. Accordingly, suppose your C1 plus C2 by 2 is smaller than suppose C3. So now this is the smaller column, okay. So this is the larger, so this will be dominated, right? That means C3 is dominated by C1 and C2. So C3 will be removed. So in that way we'll try to bring it to, in that way we'll try to bring it to your 2x2 matrix. Once we reach at the 2x2 matrix, right, we continue this process and we reach at a 2x2 matrix, then we use mixed strategy case, okay, mixed strategy case. So now the thing is that the higher order matrix can be reduced to a 2x2 matrix subject to rule 1, rule 2 and rule 3. The situation may be there if it is not dominated, right? Now coming to the if not dominated, then what will happen? If not dominated, right? If not dominated entirely, right? Suppose we get a 2 cross 2 5 4 7 3 6 9 1. Suppose we get it like this. It is a 2 cross 4 matrix, or we get 5 7 3 1 4 2 9 8 7 6 like this. Suppose we get it like this, right? 1 2 3 4 5 cross 2. So that means in general I can say this is a 2 cross n matrix or this is a m cross 2 matrix, okay. Means it is not entirely dominated, however it dominated and we reach at this type of matrix. Then here we adopt the graphical method. Here we adopt graphical method to dominate to a 2 cross 2 matrix. Okay. So what is that graphical method? Right, what is that graphical method? So this is my player A, here A1, A2, and player B is my B1, B2, B3, B4. Okay. So let me to solve one particular example, and with the process of the solution of the example, I will tell you how this method can be adopted. So now coming to a 2 cross n matrix. Suppose we consider one particular example. A 2 cross n matrix is like this. Suppose we have one example of a 2 cross n matrix. 2 cross 3 matrix we are given 1, 3, 11, 8, 5 and 2. First we will see whether it can be dominated. It is player A, A1, A2, it is player B, here B1, B2 and B3. Now whether it is dominated, we will see it. We will see it whether it is. Now what is the row minima here? As I have told you, row minima is marked by plus. Row minima here. And what is your column maxima? The column maxima is 8, column maxima is 5, column maxima is 11. You see, certainly there is no saddle point because we are not getting any point where both the star and plus are marked. Okay, no saddle point. No saddle point. There is no saddle point. Also, it is not dominated. Dominance rule is not applied. Dominance rule is not applied. Not applicable. So what to do? We adopt the graphical method. Adopt graph. Adopt graphical method. Okay. So what is that graphical method? So let me to point out here. So what is the viewpoint of A? Right. So for A we have the pure strategy and for B we have the mixed strategy, say, because A no need to dominate A, but we need to dominate B so as to we get a 2x2 matrix. Okay. So from the viewpoint of A, let me to write the viewpoint of A. From the viewpoint of A, from the viewpoint of A, view of A, it is maximin, right? Maximin means this minimum means the lower envelope, and maxi means highest point. So that means we take the graph of this. Okay, we just take two parallel lines. Vertical lines we will take two vertical lines at a unit distance apart. Okay, at a unit distance apart we take two vertical lines. Let this strategy is for my A and this strategy A1 and A2. Okay, so now we mark for A1 we have 1, 3 and 11. For A1 we have, let this be my 0 and 0. For A1 we have 1, 3 and 11. Okay, 1, 2, 3 in equal scale you take 4, 5, 6, 7, 8, 9, 10 and 11. So this is my 11. For A2 we have 2, 5 and 8. So this is my 2, this is my 5 and this is my 8. Okay. So now we join here B1. B1 is 1 and 8. B1 is 1 and 8. We join 1 with 8. So this 1 will be joined to your 8. 1 and 8 it is joined. Then next for B2 it is my B1. Next my B2 will be 3 and 5. So 3 and 5 it is joined. Okay, 3 and 5 it is joined. It is my B2. Then we join 11 and 2. 11 and 2 we join it. 11 and 2. Right. It is your B3. Then from the viewpoint of A, we have to find the maximum value, means lower envelope, the upper point. Right. We find the bounded by all the lines, below the lines we find. Okay, we find it is below the lines, right? Below these lines we will find, below this line we find, and below this line. So the intersection point is this. Okay, this is the intersection point now. This is the intersection point now. Means I say this is my lower envelope. Lower envelope. So what is the highest point? What is the highest point? So this highest point is the intersection of B2 and B3, right? So what is the highest point of this lower envelope? This highest point is, this point is my intersection of, this point is my highest point. Okay, so this point is my highest point, because in this boundary this is the highest point. So this is the highest point. Highest point of lower envelope. That means my maximin value. Maximin value. So this maximin value is the intersection of, this is my B2 and this is my B3. B2 and B3. Okay. So now this B1 is dominated, right? So B1 is dominated. Means your B1 will be dominated. So as the maximin point is the intersection of B2 and B3, so B1 is dominated. Thus the reduced matrix is here A1, A2 remain same, A1 and A2, but here B1 is dominated, B2 and B3. Okay, so it is here 3, 11, 5, 2 now. 3, 11, 5, 2. Now it is a 2 cross 2 matrix. I can say it is of the form A11, A12, A21 and A22. Now it is a 2 cross 2 matrix. Okay. So now let my essay is A1, A2, P1, P2, and SB is having B1, B2, B3, all three strategies. B1 is dominated, so it is 0. Now for my B2, it is my Q1, for B3, it is my Q2. Okay, now I need to find what is the value of the game, what is lambda. Lambda will be this plus this minus this plus this. Okay, 3 plus 2 minus 11 plus 5. Accordingly, I find what is your V. V will be 3 into 2 minus 11 into 5. This divided by your lambda. Accordingly, what is your P1? P1 will be this minus 2 minus 5 by lambda. Okay, 2 minus 5 by lambda. And my P2 is 1 minus P1. What is your Q1? And your Q1 will be here this 2 minus 11 by lambda. Okay, 2 minus 11 by lambda. And Q2 is my 1 minus Q1. And I substitute all this thing. Okay, I substitute all this thing here in SA and SB to get my answer. Okay. Now similarly from the viewpoint of here, if you are given a M cross 2 matrix, okay, you are given a M cross 2 matrix, then here A1, A2 up to AM, but B1 and B2 means B1, B2 remain silent here, and we have to dominate it from the viewpoint of here B, right? From the viewpoint of V against A. Okay, viewpoint of B against A. What is the objective? It is the minimax value. That means we have the upper boundary, and we have to take this is upper envelope. Right, we have to take the lowest point of the upper envelope, right? Lowest point of the upper envelope. So in particular, if one problem is given to you, suppose one question is, solve the following game: 1 minus 3, 3, 5, minus 1, 6, 4, 1, 2, 2, minus 5 and 0. You are given A1, A2, A3, A4, A5, A6, and you are given here B1 and B2. Right, this is 6 cross 2 matrix. Okay, we try to dominate it. So let us see whether the domination is possible here. You see your A2 here. Your A2 is superior to, okay, A2 is superior to A1, greater than your A1, is not it? And it is also superior to your A5, and it is superior to also A6. So these three things will be dominated. Right? So we reduce it. Right? After the domination, the reduced matrix here is reduced matrix here is, the reduced matrix is 1 3, sorry, it is 3 5, it is 3 5, this will there, and here minus 1 6, and here 4 1. Okay, so B1 B2 remain silent, B1 B2 remain silent, and it is my A2, it is my A3, it is my A4. In the same way we'll plot the graph, right? In the same way we'll plot the graph. So what is my graph now? You take two vertical lines, at a unit distance apart, right? At a unit distance apart, you take two vertical lines and you mark the points. Let the negative points is also there, minus 1 and minus 6, and you mark, you take a unit distance apart. That is my origin, this is my B1 and this is my B2. In B1 axis we need minus 1 3 and 4. Let it be my minus 1 3 and 4, 1 2 3, and this is my 4. And in my B2 axis I need 1 5 6. This is my 1, this is my 1 here, and this is my 4 is here, so it is 5 and it is my 6. Okay, so I join it. What is my A2? My A2 will be 3 and 5. This 3 will be joined to 5 here, 3 will be joined to 5. This is my A2. Then A3 is minus 1 and 6, minus 1 and 6 it is joined. Okay, minus 1 and 6, it is my A2. Then my 4 and 1, my 4 and 1, it is joined now, it is joined now, it is my A2. Sorry, this is first one is my 3 5 is my A2, then it is my A3, and it is my A4, 4 and 1, it is my A4. So I have to see the upper boundary, upper envelope I see. So bounded by the above the line, I have to find above the line. Okay, so above the line means above the line is this, then above this line is this, then above this line is this. So this is the upper envelope here. Okay, so this is my upper envelope. So the upper envelope we need the lowest point, right? The lowest point. So this point is my lowest point, means minimax. This is minimax, means my lowest point. Okay, lowest point. So it is the intersection of your A2 and your A4. It is the intersection of A2 and A4. So your A2 and A3 will be dominated, right? A3 will be dominated. So this will be dominated. So 3 5 4 1. What is the reduced matrix? It is 3 5 4 1, right? And for A, your A2 A4, and your B1 B2. Now it is a 2 cross 2 matrix. Since it is a 2 cross matrix, 2 cross 2 matrix, you know what is lambda, you know what is V, and thereafter your SA will be A1, A2, A3, A4, A5, A6. Your A2, A4, it is your P1, it is your P2, and rest these are dominated, means this is 0. And for B1, it is your B1, B2, it is Q1, Q2. So you find all these value and substitute here. Now coming to the final case. In the final case, what will happen? If not solvable by all the methods, not solvable by above methods, then we have to use the linear programming problem technique, LPP technique. Okay, and in particular we use what? We use the simplex method. We use the simplex method, right? We use the simplex method. I will not work out the details of the simplex method. The individual lecture you can see already, it is there. So you should see the individual lecture. So just let me to write the general form of this. So what is the general form? Suppose you are having A11, A12, A13, say A21, A22, A23, A31, A32, A33. Okay, so this is suppose a 3x3 payoff is given to you. This is player A and this is player B, and this is suppose my A1, A2, A3. This is suppose my B1, B2, B3. Now from the viewpoint of A, let the mixed strategy for B is my Y1, Y2 and Y3, and mixed strategy for A is my X1, X2, X3. Now from the viewpoint of B, from the viewpoint of B point of view, we have to minimax point. From A point of view, it is maximin. So always we frame the LPP in this viewpoint of your B. Okay, so I say viewpoint of B, right, against A1. So it will be my A11 Y1 plus, you come to the first row, A12 Y2 plus A13 Y3. Okay, so this has to be, this is minimum, so means it has to be smaller than the value of the game. Then coming to the second row, we have A21 Y1 plus A22 Y2 plus A23 Y3, which is less than your V, and A31 Y1 plus A32 Y2 plus A33 Y3 is less than is the value of the game. Okay, so now however the sum of the probability is 1, so this is your 1, right, this is your 1. So now this is my objective function here, objective, and I want to divide V throughout. Okay, if I divide V here, throughout I divide V here, and throughout I divide V here. Okay, V. So now this is my V, everywhere I divide V. You divide V throughout. Then what will happen now? Now your minimize V is same thing as, your minimize V is same thing as maximize 1 by V. This is my, I suppose, right, yi by V is equal to suppose small yi. Then it is my small, it is capitals, it is small yi by V is my suppose capital yi. So it is my capital yi, means y1 plus y2 plus y3. Okay, so this is my objective function subject to the constants. First row, A11 capital Y1 plus A12 capital Y2 plus A13 capital Y3 less than is equal to your 1. Then coming to the second row, A21 Y1 plus A22 Y2 plus A23 Y3 is less than equal to your 1. Then coming to the third row, A31 Y1 A32 Y2 plus A33 Y3 is less than equal to your 1, and the variables Y1, Y2 and Y3 are positive, non-negative. Now this is an LPP, is not it? So this is an LPP, and we add the slack variables here. We add a slack variable here S1, we add a slack variable S2, we add a slack variable S3, then it becomes your equal. Now we frame the simplex table. In simplex table, basic variable, CB, coefficient of the basic variable, solution, and the variables involved, Y1, Y2, Y3, then S1, S2, S3. Okay, you frame the simplex table, then you calculate the net evaluation del J is your ZJ minus CJ, and you continue the process till you find all are positive. Okay, for all I, then we stop the process here. And accordingly we find the value of Y1, Y2, Y3. Okay, and from Y1, Y2, Y3 we can bring back to small y1 by multiplying. So after that we find here Y1, Y2, Y3. So now Y1 into V will be my small y1. Accordingly Y2 into my V will be my small y2. Y3 into V will be my small y3. Accordingly I will get it. Now from the viewpoint of A, viewpoint of your A, right, for x1, x2, x3, we have our principle of duality, right? for x1, x2 and x3. For your x1, x2 and x3, we use duality principle. Duality principle. Right. So you should refer to my individual lecture. Okay. Refer individual lecture. Particular lecture for this. Right. So I think this one short video will help you to understand the entire thing in a single shot. With this, I thank you all for your nice patience to watch this lecture. So thank you all. Let us close this lecture.